Hi, I once again welcome you to this series of tutorials of C programming. We are moving forward and now we will learn about data types which are part of C programming language. We will start from very basics. We will first study what are character sets. A character set consists of a set of characters which can be used in different constructs of programming languages of a programming language. For example, this line given here shows us the character set of C. It consists of all the alphabets, small a to small z, capital A to capital Z, digits 0 to 9, tilde, exclamation mark, hash, percentage, caret, ampersand, asterisk, parenthesis, minus sign is equal to brackets, backslash, semicolon, single quote, comma, period, slash, underscore, plus, braces, pipe or colon, double quote, angular brackets and question mark. Note that if you have a PC 104 which is a typical US English keyboard, then the first key, that is backtick, at the rate which is above 2 and the dollar which is above 4 are not part of this key's character set. Though these three keys are allowed in strings, but they are not allowed anywhere else in C program. They are also allowed as single characters. That is, they are part of the ASCII key set. Now the second thing which we see is trigraph sequences. When I was taking the third tutorial, which was about structure of C program, I have told you about trigraph sequences, that these are passed in pre-processing stage. Now what are trigraph sequences? A trigraph sequence consists of three graphics characters. First two are always question mark. Third, when combined with first two, gives you a single one character equivalent code. For example, double question mark is equal to hash. Double question mark left parenthesis is equal to left bracket. Now what is the need of such trigraph sequences? Consider the case that I have a keyboard on which hash key is not there. Then I can use this trigraph sequence to replace the trigraph sequence with a hash. This was initially done so that people with different types of keyboard can program all over the world. Next we see we have got so many words. Auto to underscore imaginary. These are called keywords of a programming language. So you see we have how many? 4 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 37 keywords in all in C programming language. Out of these 37, we have some basic data types and some other control statements and looping statements all included over here. The basic simple data types are char, int, float, double, underscore, bool, underscore, complex. Now you have got 4 qualifiers which are mostly used: unsigned, signed, and short and long. Typically no one explicitly writes signed because that is implicit. it is assumed that if you do not give signed or unsigned, then it will be signed, while unsigned has to be explicit. Now, short and long, when applied to type, changes its range. For example, if you say short int, then it is 2 bytes on a 32-bit compiler, while a plain integer is 4 bytes. Similarly, if you say long double, then it becomes 12 bytes, while a plain double is 8 bytes. Short can only be applied on integer. On no other data type it can be applied, while long can be applied on integer and float and double. There is a const keyword which makes sure that when applied to a variable declaration, then that variable cannot be changed. There is a register keyword which ensures that when applied to a data type, then that will be stored in the CPU register. There is a volatile keyword which ensures that when applied to a variable, then that variable can be modified by entities other than the program itself. We also have static modifier, but we won't use that as of now. We will see that when we will deal with functions. A static keyword makes sure that a variable preserves its value across function calls. Now let's see some variable declarations. I have declared a char c which can contain a character within single quotes. I have an integer int I which is 7. By default it is 7, but it can also be minus 85. I have float f 12.34. I have double d, I have boolean, and I have complex. Now, note that I have written I is equal to single quote a plus b. A character is internally an integral type. That is, you can always add 2 characters. Now I see that a character is 8-bit wide, that is 1 byte. So possible number of values are 256, and by default it is signed. So the range is from minus 128 to plus 127. Similarly, I have an int. Say I have a short int. Then its size is 2 bytes, that is 16 bits. Then its size will be minus 2 to the power 15 to 2 to the power 15 minus 1. Say I have float, then its range will be determined by the floating point expression. I will give finally the ranges of all the documents, of all the ranges in one table later on. Similarly, I will give you the range of double which is possible. A Boolean is internally like a char. That means it is also an integral type, but with a difference. If you assign it a 0, then its value is 0 or false. But if you assign it any other value, non-zero value, then it becomes 1 or true. So for example, we have assigned 3, so it will become 1. We have one more data type for mathematical operations, and that is underscore complex. It consists of 2 parts, real part, that is 3, and complex part, that is 4. You must say I for the complex part. Let us see about printing. A plain character is printed as C, while an integer is printed as D or I. A float is printed as F. A double is printed as LF. Again, a Boolean can be printed as D. You can also print it as I. Now, this 3 is by default double, and this 4 will be double. So I am printing it as double. Note that by default 6 significant digits are there after decimal. So if we print it, it will show us that. Let us try to run this program and see what is its output. So since we have enabled parallel build, we simply run it. Okay, let's save the changes. So you see, character C has been printed, that is the variable C has been printed as A. Note that there is no single quote here. I has been printed as 195. I has been printed as 195, which is the sum of A and B. A's ASCII value is 97 and B is 98. Note that how 6 significant digits are there after floats here. Also note that how Boolean variable is printed as 1. Let us put a twist to it. Let's make this negative. Let's make this negative and then we run this program. So minus 3 is also 1. Let us try to make this unsigned. And we run the program. You see, 850. Oh, oops. We'll have to comment this out, otherwise I'll be never getting its value. Okay, you need to print it as U. And this is the unsigned value of the integer. Typedef acts as a synonym creator. Let us learn about the ranges of some simple variables. I'll show you just one example. Note that depending upon your compiler, the size of plain int is subject to either 2 byte or 4 byte. I have a 32-bit compiler. Our GCC is a 32-bit compiler which will give you 4 bytes. Older Turbo C compilers will give you an output of 2. So to repeat a very important concept, I will say that if width of type is n, range is 2 to the power n minus 1 to 2 to the power n minus 1 minus 1 for signed. Range is 2 to the minus 2 to the power 0 to 2 to the power n minus 1 for unsigned. So we have seen this unsigned int. We can also say this is unsigned short int. Then the output will change. See, the maximum possible value of float and double is governed by its IEEE specification. I would rather say real numbers are governed by IEEE specification. Also note that these are not accurately represented. For example, not all fractional numbers can be represented accurately in binary. The reason being that if you have base m, computer is base 2, so the only factor of 2 is 2. So what a computer can convert into binary is these 1 by 8, 1 by 16, 1 by 32, and so on. Any other fraction cannot be converted by 1 by 2 to the power n. Any other fraction cannot be converted completely into binary. Now suppose I have a number m which has some factor m1 multiplied by m2 multiplied by up to mn. Let's say this is a suffix, or rather subscript. So in base m, if the denominator consists only of these n factors, then and then only that number can be converted to binary. This is a very important property of numbers, and you must take this into account. We will see important implication of this on floating point numbers when we will consider the control flow statement if. That why a float should never be used in if comparison. There are more things to be discussed which I will show you in my next meeting. Also, there is one more basic data type which is called void. But you cannot declare a variable of type void. Void is equal to 1. This will give you compilation error. So it says that void is incomplete type. What do you mean by incomplete type? By incomplete type we mean that a type whose size cannot be determined. But you will say, let's try size of operator. Yes, you can try, and size of will give you 1 byte. But specification says its size cannot be determined. Implementation implements it in a different fashion, and that is because of practical reasons. Because it cannot give any arbitrary value, so it gives you 1 byte. And similarly, array of void types cannot be created. Pointer of voids can be created. So that's it for now from data types. In the part 2, we will see more about these data types. Thanks for listening to me. Happy coding. See you then. Bye.